Dear student, today in the standard 9 we are taking the chapter 9, and in that let us take the first law of motion. So in the first law of the motion, first of all we have to understand the Galileo's observation. So in the past time, Galileo he deduced that objects move with a constant speed when no force acts on them. So whenever any object is moving with constant speed and there is no force act on them, then object continue its motion. He observed that when a marble rolls down an inclined plane, its velocity increase. You can see in the figure A. Okay, this is our common observation. When a marble rolls down an inclined plane, then obviously its velocity increase, which is given in the figure A. In the same way, from the figure B, when the marble climbs up an inclined plane, its velocity decrease, figure B. Galileo argued that when the marble is released from left side, it would roll down the slope and go up on the opposite side to the same height from which it was released. You can see in the third figure, when the marble rolls down from the left side and then it climb up in the right side, then it will reach to the same height. You can see the orange color line, okay, that is at the same height. The marble will reach to the same height. If the inclinations of the planes on both the sides are equal, then the marble will climb the same distance that it covered while rolling down. So this is the Galileo's observation. Now another observation, if the angle of inclination of the right side plane were gradually decreased, then the marble would travel further distance till it reached the original height. Again, if the angle of inclination of the right side plane were gradually decreased, then the marble would travel further distance till it reached the original height. Second observation, if the right side plane were ultimately made horizontal, means angle is 0, that the slope is reduced to 0, the marble would continue to travel forever trying to reach the same height or the distance that it was released from. So the unbalanced force, external force on the marble in this case are 0. It thus suggests that an unbalanced means external force is required to change the motion of the marble, but no net force is needed to sustain means maintain the uniform motion of the marble. In the practice situation, it is difficult to achieve a zero unbalanced force. Zero unbalanced force. It is very difficult to achieve zero unbalanced force. This is because of the presence of the frictional force acting opposite to the direction of motion. Thus, in practice, in day-to-day life, we can take the example of the marble. Then the marble stops after traveling some distance due to this opposing force. The effect of frictional force may be minimized by using a smooth marble, a smooth plane, or providing the lubricant on the top of the planes. So you have to make the surface as smooth as possible, then the effect of frictional force, that is the opposing force, may be minimized. In the picture, you can see the first picture at the left side, the marble moves on the horizontal direction on the rough surface, that produce more frictional force and it stop after some time. But in the right side figure, you can see if the surface is smooth surface, then the marble will continue its motion, because here the frictional force is minimized to 0. So, now from this we are coming to the point of the Newton's first law of motion. Newton further studied Galileo's ideas on the force and motion and presented 3 fundamental laws that govern the motion of objects. These 3 laws are known as Newton's laws of motion. So, here first law of motion, what is that? All objects remain in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. Meaning of this law is what? All the objects remain in a state of rest, means if the object is steady, it is remain steady, or of uniform motion in a straight line, means it remain in uniform motion or it continue its constant velocity unless compelled to change that state by an applied force, means unless any external force is applied. If no external force is applied, then object will remain as it is in the state of rest or in a state of uniform motion. In other words, the first law of motion can be written as all objects resist a change in their state of motions. All objects resist means oppose a change in their state of motion. The tendency of objects means here undisturbed object. The tendency of undisturbed object to stay at rest or to keep moving with the same velocity is called inertia. Thus, the first law is also known as the law of inertia. Now, let us take some day-to-day life observation based on first law of motion. We tend to remain at rest with respect to the seat in bus until the driver applies the brake to stop the bus. Okay. We tend to remain at rest with respect to the seat in the bus until the driver applies the brake to stop the bus. With applying brake, the car or the bus slow down, but our body tends to continue in the same rate of motion due to the inertia. Thus, seat belt is necessary for this. Other experience is encountered when we are standing in a bus and the bus begins to move suddenly. This is also our common experience when we are standing in a bus and the bus begin to move suddenly. So, now we tend to fall backward. What happened in that case? We tend to fall backward. This is because the sudden start of the bus bring motion to the bus as well as to our feet in contact with the floor of the bus, but the rest of our body rather than feet oppose this motion because of its inertia. Third observation, when a motor car makes a sharp turn at a high speed, we tend to get thrown to one side. This can be also explained on the base of the inertia. We tend to continue in our straight line motion. When an unbalanced force is applied by the engine to change the direction of motion of the motor car, we slip to one side of the seat due to the inertia of our body. So these are the some day-to-day life observations based on the first law of the motion. Now let us take the some things about the Newton's first law of motion. This first law defines force as the external effect due to which the state of motion of a body can be changed is known as force. The external effect due to which the state of motion of a body can be changed is known as the force. Thus, Newton's first law of motion tells us that due to the force, the state of motion of a body can be changed, and as a result, velocity of the body is changed due to the force only. So, Newton's first law indicates that there should be some relation between force and acceleration. This relation is given by Newton's second law. So, to understand second law, first we have to understand a momentum. Now, the momentum is the quantity. It is the product of mass and velocity. So, that is known as the momentum P. So, P is equal to m into v. The unit of the momentum is kilogram meter per second or gram centimeter per second. So, it is having value means magnitude as well as the direction. So, it is a vector quantity. When we throw a ball, bring the ball into motion from state of the rest, or we stop a ball means rest from motion, we change the state of the motion. So, for changing the momentum, we need force in more or less amount. This clearly suggests that there should be some relation between force and change in momentum. So, we have to find out what is the relation between force and the change in momentum. Newton gave this relation in form of Newton's second law of motion, which is as the time rate of change in the momentum is directly proportional to the resultant external force, and the change in momentum is in the direction of the resultant external force. Again, the time rate of change in momentum means delta p upon delta t. Delta p means change in momentum, delta p upon delta t means time rate of change in momentum is directly proportional to the external force, resultant external force. So, delta p upon delta t is proportional to the f, and the change in momentum is in the direction of the resultant external force. So, we can write in other way, f is equal to delta p upon delta t. From it, we will also get equation f is equal to mass into acceleration. Now, Newton's second law of motion. Suppose an object of mass m is moving along a straight line with an initial velocity u. It is uniformly accelerated to the velocity v at the time t by the constant force capital F. Thus, initial momentum of object equal to Pi is equal to m into u. In the same way, final momentum of the object is Pf is equal to m into v. So, the change in momentum, that is the final momentum minus initial momentum, Pf minus Pi is equal to mv minus mu equal to m into v minus u. The rate of change of momentum in that way is equal to change in momentum upon time interval equal to m into v minus u upon t minus 0 means m into v minus u upon t, and f is proportional to m into v minus u upon t. So, f proportional to m into v minus u upon t means f is equal to k into m into v minus u upon t. But v minus u upon t is what? Change in velocity upon time interval. So, it is the acceleration. So, f is equal to k m into acceleration a. K is the constant of proportionality. So, we get the value of the k is 1 due to such a selection of the unit of force F equal to ma, where 1 unit of force is equal to k into 1 kilogram into 1 meter per second square. So, we get k equal to 1 unit. By putting in equation, we get F equal to ma, a equal to v minus u upon t. So, F is equal to m into v minus u upon t. So, this is the equation of the force. The unit of the force we know, that is kilogram meter per second square or Newton. Now, the second law of motion gives us a method to measure the force acting on an object as a product of its mass and acceleration. So, F is equal to m into a. Now, another quantity, that is the impulse of force. So, what is the impulse of force? The effect of the force on a body depends on magnitude of the force, time period for which the force act, and the direction of the force. Okay. Effect of the force on the body, that is depend on value of the force, the time period for which the force act, and the direction of the force. So, product of time period for which a force act on a body and the force is called the impulse of force. So, impulse of force is equal to F into delta t. According to the second law equation, F is equal to delta p upon delta t. Thus, delta p is equal to F into delta t. So, impulse of force is equal to F into delta t, and this impulse of force is also equal to the change in momentum. Example, a fielder in the game of the cricket pulls his hand while catching the ball. By doing so, he is increasing time period in which momentum of the ball is going to decrease due to this. So, the F decrease due to the time increase. As a result, he can catch the ball without injury. Now, based on this impulse of force, we are deriving the another law of motion, that is the third law of motion. According to it, a single force does not exist in the nature. Remember, a single force does not exist in nature. Forces are always exist in pair. Forces are always in pairs. So, what is the third law of motion? Definition is, in an interaction between two bodies, the force exerted by the first body on the second body is equal and opposite to that exerted by the second body on the first body. Means FAB is equal to FBA. So, now let us take the two objects A and B. So, force exerted on the A due to the B, that is the FAB, we can say it is as a action. So, the force exerted on the B due to the A, that is taken as a reaction. So, FAB is equal to minus FBA. So, any force can be named action, then the other is reaction. Moreover, action and reaction always act on different objects. Thus, Newton's third law of motion is what? Action and reaction are always equal in magnitude and opposite in direction. Let us take some illustration based on the Newton's third law of motion. First, a swimmer pushes the water backward and he moves ahead. Second, if a person jumps out of a boat, the boat is pushed in the opposite direction. Third, a boatman pushes water backward using oars and moves the boat ahead. Now, another quantity, we are taking the conservation of the momentum. What is the conservation of momentum? Means the momentum is conserved. The quantity momentum is conserved means it is remain constant with respect to time. That is the conserved quantity. The law of the conservation of the momentum is what? In absence of an external force, the total linear momentum of the system of the two or more interacting bodies remain constant. In absence of external force, total linear momentum of the system is remain constant in other way. Now you can see in the diagram, first before collision it is given A and B, they are coming from different direction having the initial velocity u1 and u2, and they collide at the collision point. After collision their direction is changed as well as the magnitude is also changed. So the object A's velocity is become now v1 and object B's velocity is become v2. In the next session we will continue this conservation of the momentum and its equation. So make the notes of this first law of motion, second law of motion, third law of motion, impulse of force, linear momentum. Okay, so we will continue in the next session about the conservation of the momentum. Thank you.